Hi guys, Mr. Wallace here. I'm going to be taking some of your online lessons via video for a little bit of time. I've got myself on a blue screen so I can cut in and out as needed. And if you have any questions at all that aren't answered in this video, make sure that you're asking whatever teacher it is that uploads this for you. Okay, so we'll just get started straight off the bat. I'm going to disappear from the screen and we can get cracking. What we're looking at as a first kind of new topic after Easter here is symmetry. Okay, so we're going to focus specifically on lines of symmetry, but what I want you to be able to come back to at the end of the video is these questions here and make sure that you're comfortable answering them as you go through the practice material and anything you're asked to submit by your teacher. Okay, I'm not going to read them out, but they're there and I expect you to be taking a bit of notice of them. For a line of symmetry on a 2D shape, to be a line of symmetry, it has to follow a couple of simple rules. Okay, the first rule is that it absolutely has to split the shape into two equal parts, or two halves. Okay, once you've found a line that's splitting the shape into two equal parts, each of these halves for the line to be a line of symmetry also have to mirror each other. Okay, and to demonstrate that, what I've got here is just the capital letter A, which only has one line of symmetry. Okay, and that line of symmetry is there. The reason this is a line of symmetry is because if you look at any pair of points that match up on each side, they are perfect mirror images of each other. Okay, so this distance here is the same as this distance here. And that's true for any line of symmetry. You can't find any other line of symmetry on a shape like this A, which is why we say it only has one line of symmetry. If I was to try and draw one here, for example, these points wouldn't mirror across. They'd end up somewhere like here. Okay, if we look at that in a slightly more geometric situation, such as a rectangle, you want to be thinking about where there could possibly be lines that are cutting this in half. Okay, now the first one that would hopefully be obvious to you is a line straight up and down, cutting this in half. Okay, you can see here, if you were to fold this in half, all the points would match up. Okay, this point here is 1, 2, 3, 4, 5, 6 spaces away from the line of symmetry, and then 1, 2, 3, 4, 5, 6 lines away. So these 2 points match up. Okay. The other place there's a line of symmetry on this shape, and I'll just get rid of this one so that we're keeping it nice and clean and simple, is here. Again, if you were to fold this in half vertically, so if you were to take this line and fold it down so that it met up with this line, this point here is 3 away from the line of symmetry, and this point here is 3 away from the line of symmetry, so they'll match up. And the same is true of this point here and this point here, so that's also a line of symmetry. Okay, so far we can comfortably say that there are two lines of symmetry. Pen's going a wee bit on this rectangle. Okay, however, you might be tempted to say, well, wouldn't this diagonal here, it cuts it in half, couldn't this be a line of symmetry? Okay, and there's a reason that I'm hoping I'll be able to show you quite clearly that this isn't the case. Okay, I'm going to grab myself a little dotted line here just to make it a bit simpler. Is if you think about this point here, okay, and it has to be mirrored straight across. Okay, so it has to go straight across this line here. Now what that means is when you take this point here, it has to go the same distance here and the same distance here. So it's going to end up somewhere a bit more like here. Okay, and the shape that you end up with, if you draw that out, is this one here. Okay, so it doesn't match up with a rectangle. What that means is this line here can't possibly be a line of symmetry on this rectangle. Okay, I'm going to ask you to pause the video with this first little example and just have a think about, on this regular pentagon, all the sides are the same length, how many lines of symmetry will this have? Okay, I'll give you a couple of seconds and then we'll go over it, but make sure you do pause and have a go at this yourself. Okay, So hopefully the first one is pretty straightforward for you to spot. There's a line of symmetry splitting it in half here, okay? If you take this point, it's going to translate straight across to this point, translate straight across to this point. Okay, so that's a nice line of symmetry to get us started. Now, because the shape's regular and all the sides are the same length, that means you can do the exact same thing as you did with this line of symmetry, but through this point here, okay? And then you can do the exact same thing again, but through each of the other corners, okay? So you're going to end up with lines of symmetry here, here, and lastly, here, okay? What that means is we have 1, 2, 3, 4, 5 lines of symmetry. Okay, because this one here matches up with 1, this one matches up with 2, and so on. So your final answer, if you were given a question like this and asked how many lines of symmetry are on this shape, you'd have to say there are 5 lines of symmetry. And that would be you. Nope, dodgy line, but we'll go with it. Okay, so that's the first type of question that can be thrown at you, and you just have to take your time, look at the shape, and make sure that each of the points is reflected or mirrored across the line perfectly, okay? Now, the second type of question you could be asked for these, and I'm trying to keep this video nice and short, so we'll go through this as quickly as we can, watch it a couple of times if it helps, is reflecting across a line of symmetry. So what it's asking you to do here is, it's saying you've got this shape, but it's only half of the shape. Can you draw the other half if it was mirrored across this dotted line of symmetry, okay? So this is our dotted line of symmetry for the first of these two shapes. Can we reflect this or mirror this shape across the line of symmetry? And the easiest way to do that is to just take each point, count how far it is away from the line of symmetry, and go the same distance across on the other side. So what that means is if we take this point here, okay? This point here is 1 square on the screen away from the line of symmetry. So that means we're going to go 1 square to this side, and we're going to make that part of our shape there. Okay. The second point is also 1 away from our line of symmetry, so it's going to be here. And then it's just 2 down, joining it up. So it's going to go in there like so. Okay, pretty straightforward. Our next point is this one here, and you should see it's 1, 2, 3 squares away, so we're going to come to the other side and go 1, 2, 3 squares. Okay, that means this point's here, and we're just going to join it up with this one. Okay, and to make sure I don't have a ruler, I'm working on a computer screen, draw these as neatly as you can if you come to one of these questions. Our fourth point, yeah, is going to be here, and it's again 3 away. Okay, so we're going to come 3 to the other side, and that's our point there. We're going to join it up with this one. Next point is this one. You should be getting the idea of it just now. This is just 1 away from the line of symmetry. So it's going to be here, and we're going to join it up. And then our last point is this one here, which is 1 away. So we're just going to join this line down to that point, mirroring it there. And then we complete our shape by just coming in here. Okay. So that's the first one, done and dusted. Second one is the exact same idea. The only difference is you've got your line of symmetry on a diagonal, on a slope, okay? So you have to take a wee bit more time thinking about what you've got. We're still just going to look at each point and join them up as we need to, okay? So we'll start over here. We're reflecting across this line of symmetry. We'll start with our first point coming from here up, okay? So here, can you see that we're 1 diagonal across here away from the line of symmetry? So that means to reflect this point, we're going to come 1 diagonal down here and say that that's our mirrored point. Now you'll notice when we've got the diagonal line, we had to go 2 up to get to this point here, and to get to its reflection we're going to have to go 2 along. Okay. Next point is this one here, and you can see it's just a half of one of the squares away. So that means we're just going to come this other half over here to join up to this point here. And again, you'll notice to join them up here, we had to go along. On this side, it was up and down. Okay, now there's only one more point we need to actually finish this shape off, and that is this one here. Okay, and it's 1, 2 diagonals away from the line of symmetry. So we're going to come 1, 2 along here, and this is where we're going to be drawn to. Okay, so we went 3 up here, so we're joining it up by going 3 along here, and then all we need to do is complete the shape by coming straight up here. Okay, again, you'll hopefully do a better job than me because I don't have access to a ruler. And really that's all that's involved in drawing one of these. Okay, we're running a little bit over where I wanted to, but I've got one last example I want to show you before we give up. Okay, and that's this one here. The only difference between this and the previous examples is we have 2 lines of symmetry to deal with. Okay, so all we do is deal with each one separately. Okay, and what we'll do, just as an example of this, is we'll go through looking at the vertical line of symmetry first, and we're going to reflect this shape across here. Okay, so we've got this point here is 1 square away, so that means our first point's there. This one's also 1 square away, so it's going to be here. Okay, we're just counting that 1 square away from the line of symmetry, so 1 square away on this side as well. Now, this point is 2 away, but it hasn't gone up or down anywhere, so we're just joining up that bit there, mirroring. Okay. Next, we're going to look at this point, and we'll see that it's 1, 2, 3 away from the line of symmetry, so we're going 1, 2, 3 away over here, and then joining these two up as neatly as we can. Final point here is 4 away, it's just the 3 from the last one, and then an extra one out, so we're coming out to here, okay, and then we just join up that last point that's on this line of symmetry, which is also 4 away on each side. And that's us reflected across the vertical line of symmetry. So all we have to do now is take this whole shape that we've just created and reflect it across this horizontal line of symmetry. Okay, I'm going to go through this quite quickly. Please make sure you take your time and have a look at it. Okay, so we're going 1 down because we're 1 up here, along this 1 to meet this point here, and then this point's 3, so we're going 3 here to get to this point. This point's also 3 away. Oh, need to give that a wee fix, don't want that showing up. And then this one is 4 away, and then we join up. Same idea on this side, you're going 1 down, 1 along. You've got your diagonal section going to here because they're both 3 away. Along to this point, and then up and close the shape. And that's you done. Okay, and it's really just about taking your time with these. If you make any wee mistakes, you can always go back and have a fix of them. Okay, there's only one last little point that I really want to bring into this discussion, which is shapes that don't have any lines of symmetry. Okay, it's perfectly acceptable in some of the questions you might be asked for a shape to actually have no lines of symmetry, and the easiest way to show this off is with the 2 shapes I've got here. Okay, if you look at this F, there is nowhere that I can place a line that splits this in half, okay, where the points are going to be perfectly reflected. See, there's something wrong here. This isn't going to match up. So we don't have any lines of symmetry on this F, and that is perfectly okay. That can happen in some of the questions, so keep an eye for it. 0 lines of symmetry here. Okay, same goes for our card. Okay, now you might be tempted to think we've got a rectangle and there's probably lines of symmetry here and here. Okay, and you'd be right if it wasn't for these symbols here. Okay, if I try and reflect this across the horizontal axis of symmetry, you'll see that it's not matching up. If I try and translate either of them across the vertical line of symmetry, it's not there, so it doesn't line up. So this shape also has 0 lines of symmetry, and you have to be careful of that because they do like to throw it into some of the questions. Okay, so 0 lines of symmetry there as well. And at that's us, guys. So thanks for taking the time to watch this today. I hope it helps you with your homework as you go on practicing through it this week. You'll have submissions. Again, it might be me, it might be another teacher that's assigning it to you. Just make sure that once you've got to the end of this video, you're quite happy to say that you know how to answer each of these questions up here. Okay, and the last thing I'm going to ask you to do, just as a bit of extra for you to think about in your own time, is try and think about how many lines of symmetry you would see in a circle. Okay, see if you could draw it out, or maybe look online, see if you can find an answer for yourself, and hopefully that'll give you a wee extra something to work on top of the homework. Okay, but otherwise, thanks guys, hope you have a great week, and take care.